A seamless pipe 1 meter diameter contains a fluid under a pressure of 1 point Newton per mm square. If the permissible tensile stress be 100 Newton per mm square, find the minimum thickness of the pipe. So there is a seamless pipe and its diameter is 1 meter, okay, contains a fluid under a pressure of 1.5 Newton per mm square. So here internal pressure is 1.5 Newton per mm square. The permissible tensile stress. So permissible tensile stress. So permissible tensile stress is also known as circumferential stress or hoop stress. Remember, hoop stress or is also known as circumferential stress. Circumferential stress or tensile stress is also known as tensile stress. Tensile stress. So generally hoop stress denoted by sigma h. Here permissible tensile stress, how much is given? Nothing but hoop stress, how much is given? Is given 100 Newton per mm square. 100 Newton per mm square. 100 Newton per mm square. So what is the diameter of the pipe? So diameter of the pipe is 1 meter. So let us convert meters into mm. 1 meter is equal to 1000 mm. Because here stress is already in mm meters, mm square. Okay, na? Millimeters. So we have to convert diameter also in terms of millimeters. Next you also given internal pressure, fluid pressure. So internal fluid pressure Pi is equal to how much? You given 1.5 Newton per mm square. 1.5 Newton per mm square. Okay. So hoop stress or circumferential stress or tensile stress. So this is the information given in the question. So we didn't mention anything about internal diameter and external diameter. Okay. So at the same time, given only permissible tensile stress, only hoop stress. Find the minimum thickness of the pipe. Here to find. So what we need to find? We need minimum thickness of the pipe. Minimum thickness of the pipe. Let us say T min. So how do you get minimum thickness? So since you didn't mention anything about internal diameter and external diameter, at the same time you given only tensile stress, hoop stress, so this problem comes under thin cylinders concept. Thin cylinders concept. Okay. So in thin cylinders, hoop stress or maximum tensile stress sigma h is equals to our circumference formula. What is the formula? Pi d by 2t. Here T minimum, we need minimum thickness, so T minimum. So hoop stress, already we have hoop stress how much? 100 Newton per mm square. Internal pressure how much? 1.5 Newton per mm square into diameter 1000 mm by 2 into thickness T minimum. We need T min. So 2 ones and 2 500s, 2 ones and 2 500s. Okay, 100 is equal to 1.5 into 500 by T minimum. 100 ones and 100 5s. Transpose T minimum. 1 into T minimum, T min is equal to 1.5 into 5. So 1.5 into 5 how much? 7.5. So minimum thickness of the cylinder. Minimum thickness of the cylinder is 7.5 mm. 7.5 mm. So this is the final answer. So this much thickness we require to resist fluid pressure of 1.5 Newton per mm square. Okay, so minimum thickness is 7.5 mm.